Hi guys, BuildZoid here, and today we're going to be doing another one of these rather boring memory overclock videos. So as you can see, we have, 15 instances of memtest. 1, 2, 3, 4, 5, 6. Yeah, I think it's 15. Yeah. So 30 gigs of memtest running here, because we are testing as you can see in the system, there is 4 DIMMs installed. That's these 4. Come on, camera. There, yeah, so 4 of these are installed. So that's the Micron rev.E memory. Yeah, it's all running at 3600 megahertz right now. So, it's rated for 3000, which isn't all the best overclock. I was really hoping to go over 4000, but the motherboard just doesn't seem to, it takes way too long to train the memory when booting up, and if I go over 3733, if I go over 3600, it just doesn't train at all. So I'm going to assume that the board just isn't set up to deal with these, or, yeah, it just doesn't know what to do with them. So it's kind of unfortunate, but even then, 3000, 3600 over 3000 is like a 20% overclock, and we have the timings tightened up, so, yeah. So what is that? 3600 over 3. Yeah, that's like a 20% overclock right there. So, yeah, and as you can see, it's only passing 100% right now, but the thing is, it's 32 gigs of RAM. It takes forever to let this run out to, if you were actually seriously stress testing your memory, you should be running this out to like 300, 400%. If if you have a workstation where stability is really important, you would actually want to run out to 1000%. Obviously, it's on an open air test bench, so thermally, the conditions here are very forgiving, especially because the room is quite cold. So, if you were actually if you wanted to stress test a memory overclock, you should really have your GPU loaded up at the same time or something, so that you actually have the correct internal case temperature when you're stress testing. But this is on an open air test bench, and I can't be I'd have to hotbox the memory or something to get it to, I don't know, 40, 40 degrees ambient right around the memory sticks, and well, that's just too much work to do. So anyway, similar to how I can't be bothered to let this run out to 400% because I have things to do, and yeah. So anyway, we're at 100%, so the overclock is at least somewhat stable. I would not be surprised if this went all the way to 400% with 0 errors, but anyway, so we're just going to close all of that down. We're going to do a quick IDA test. Unfortunately, because we are running just 3600 megahertz, the performance really isn't anything to write home about. I mean, it's not bad. It's better than running 3000 megahertz, but it's still slow. And yes, we are using the Gigabyte Z390 Aorus Master here, so in case you didn't recognize the motherboard, and a 9900K. So yeah, the latency is not great. 41, well, we're around 42 nanoseconds, which for an Intel platform, if you're pushing the upper limits of Z390, you can do 35 nanoseconds. But the upper limits of Z390, just you need B-die. So for you need B-die, you'd need to be running a higher frequency, I think. You'd probably also want to ideally be on an ITX motherboard, or just something like an Apex or a Dark or a Gene, right? So basically, if you've got 4 DIMM slots, yeah, the latency doesn't tend to go that low. And also, this is rev.E, which is it just doesn't do low latencies. It's loose. It's really, really loose. So anyway, bandwidth wise, we're hitting the limits of what you can do on 3600 megahertz. Because for 3600 megahertz, the theoretical maximum throughput is 57.6 gigabytes per second, which, okay, so in the read department, it's not really that close to maxed out yet, as we are at only 53.5 gigabytes per second. But the write is basically maxed out, yeah, so we're 53.5, and then for write, we should be getting 56, I think. Yeah, we're getting a little over 56, so that's pretty much at the theoretical limit of what a dual channel memory setup can do at 3600 megahertz. Because we are running dual rank, we're running some pretty tight timings. So let's go into the BIOS and actually take a look at the settings. So this is on the latest BIOS for the Z390 Aorus Master. I don't think, like, if I'm correct about my assumption that, it's just a BIOS thing that's making these memory sticks not clock as high as I'd like them to, then I don't think Gigabyte's going to be putting out another BIOS for this board, honestly. And if they do, then it's probably going to be for some, like, it's not going to be to make better memory overclocking support. It's going to be for something else. So, anyway, here we are in the BIOS, right? Should I put this? I don't know. We'll just have that scaled like that. Anyway, so here we are in the BIOS. I just you don't need to set this. I just have that set because the 133 divider, if you're initially doing memory testing, the 133 ref clock is generally more stable than the 100. So like 4133 tends to work better than 4100 and that kind of thing. So yeah, 1.4 volts on the CPU, but we do have a lot of droop here, and really you shouldn't actually be looking at my CPU settings, right? Like, we're on high LLC, which is pretty droopy. So, anyway, so I do have the training voltage set to 1.5 volts. I'm not sure if that's actually necessary. I've just not bothered to check if this board has the training voltage, tracking the, like, if training voltage on auto actually tracks the DRAM voltage that you set. And since I can't be bothered to check, it's easier to just set both to the same thing manually, which is a little bit inconvenient, but at the same time, there are situations where you actually would want a different training voltage from your running voltage, and in those scenarios, having the training voltage setting can be very, very helpful. Anyway, VCCIO, we're looking at 1.2 volts, system agent 1.28. These might be a little bit high, but they're still well within the safe limits for a 9900K, right? We're well below 1.35 volts on both of them. So, yeah, this is daily. Like, you could literally daily this. Like, these settings that I'm running here, they're meant to be daily. This isn't some ridiculous, aggressive overclock. 1.5 DRAM voltage, which is fine for rev.E. Yeah, 5 gigahertz CPU, 4.5 gigahertz ring. The thing is, well, ring just takes, like, the higher your ring go, like the more ring voltage, the more ring clock you want to run, the more core voltage you're gonna need. And I couldn't be bothered to properly stabilize, like, I'm not interested in pushing the ring ratio as high as it can go, and that will, reduce your latency a bit in IDA. Anyway, so here we are in the memory settings. So disable fast boot. This is so that the memory actually trains every time you boot. If you have fast boot enabled, one of the things that fast boot, like how fast boot speeds up the boot procedure, is you just skip the memory training and hope that everything works. And it'll just use the settings that it trained with previously. So yeah, which once you're done with your memory overclocking, there's really no reason not to just put it back to auto most of the time. Anyway, next we go to the memory channels timing. So we're running 15, 19, 19, 36 primaries, TRC 55, which TRC is just the TRAS plus TRP. Those two just added up. TWR 15, TCWL 14, TCW 12 will not post. Just if you were wondering. TRRDS 4 for WTRS 3, WTRL 6. Actually, the thing about the WTR timings on this version of the BIOS, you can't set those. So while I do have those set, the reason why they're actually at the values they're supposed to be at is because I've set the WRRD SG timing and the DG timing here, the WRRD DG. So this is what's actually setting the WTRs, because if you try to set the WTRs, the motherboard will not adjust the WRRD timings for you, because, basically the WRRDs and the WTRs are linked. So if you want a certain, for a specific configuration of the WTRs, there's a specific WRRD timing set that you need to run. And since the motherboard won't automatically configure the WRRDs for you, you need to set the WRRDs so that you get the WTRs you want. So that's why these are set to 26 and 23 manually, because otherwise we wouldn't be getting 3.6 up in the top part. As these, on this BIOS, these take priority over the WTRs. There's a lot of other motherboards where you set your WTRs and they will automatically configure your WRRDs for you. So you wouldn't have to deal with this, but yeah, this version of the BIOS just requires this. All of the tertiaries are just set as low as that. Like, I literally just went through and took one tick of timing out of each one, and it was like, oh, it works or it doesn't work, and then Took 1 tick of timing again out. So, yeah. So most of these are actually auto, like the 7467, that's basically auto settings, then 7477. Actually, this, yeah, that's also, like, the motherboard would default to that. Then the 66 here is also, the motherboard defaults to that, I think. The 11s here are actually an improvement, and they do give you a small bump in terms of memory bandwidth. They don't really do anything for latency. We go down here, this is all auto. There's no reason to... Like, I tried messing around with this when I was trying to push over 3600 megahertz, but I really wasn't getting anywhere. So, yeah, that's all auto now, because on auto it works just fine. What else is there? Right, TCKE1. TREFI, I just have it set to 32,000. It might be able to go higher, but TREFI is kind of annoying to stress test. So, yeah, I just like to go to 32,000 because 32,000 almost always works. Command rate 1T, this is a T topology motherboard, so if you actually have 4 DIMMs like we're running here, it will do 1T. If you're running only 2 sticks, it won't do 1T, which is kind of funny. So, yeah, T topology motherboard, 1T command rate, you need 4 memory sticks. If you're going to run 2 sticks, you're going to be running 2T command rate. Even at 3600 megahertz, it's going to be 2T. So... yeah, TFAW 16, because the RRDs are 4, RTP 10, TRFC 590. There are some rev.E memory kits that can do lower TRFC than this, but mine can't. Not reliably anyway, so I just run 590. But there are definitely some kits out there which could maybe, like, I've seen some really, really, like, top bins of rev.E can actually go really low on the TRFC. This is not a top bin. This is like the lowest bin of rev.E that, you know, Crucial makes, right? Because it's just DDR4 3000, 1.35 volts. So, anyway, then we have TCCD, S, and L, just 4.6. You know, small, like, it makes a small improvement in bandwidth there, but 4 is an auto timing, so you can just copy these well... you shouldn't, like, the thing is, you shouldn't really copy the timings, but this is kind of what you could aim for, okay? And I did literally go through these and just take 1 tick. Well, okay, no, I didn't do that, because I already know how a lot of memory times, so a lot of the time I just skip straight to the settings I want to run, and then when they don't work, that's when I start loosening it out. But... yeah, so this is basically the timing set I'm running here. It's worth noting on Z390, TRCD and TRP, and actually Z370, Z270, Z170, all of the LGA 1151 platforms, your TRCD and your TRP timings are linked, as in they have to be the same thing. So you can set your TRCD to like 18 and your TRP to 19, and I do believe it's just going to set both to 19. I'm not sure which one takes priority, but I think it's going to, you're just going to end up with 19. So there's no point, like... doing something like 19, 14, like that won't work. That won't work. You just set them both to the same thing because the platform doesn't support setting them separately, which is why I think ASRock and Asus BIOS actually don't have them separate. Like, you can't configure them separately. They're merged into one setting because you can't set them separately anyway. So this is just kind of a leftover of Gigabyte, you know, having a standardized BIOS layout, and in their standardized layout you have separate TRCD and TRP timings even on platforms where that's not even supported. So yeah, that's pretty much it. You know, that's the overclock. There's really not very much to it. Just 1.2 volts IO, 1.28 volts SA, which again for the frequency might be a bit high, but then we're running dual rank, so you know. And it's stable. It's stable enough anyway. So, yeah, I'll call it that. 1.5 volts memory voltage, 1.5 volts training voltage. There's really, like, there's not really any memory overclocking settings, related settings in this menu right here. So you can just kind of ignore anything down there. And then there's the timings, which, yeah, this is it. That's all. That's all you need to. That's that. So. I guess, well, I'm thinking if I should show you anything more, but I don't really see the point. Well, we could bump up the frequency, I guess, right? And I can show you how it's not going to post when we do that. Oh, no, there was one thing I wanted to try. I was wondering what would happen if we just ran all auto timings in terms of performance. So previously we were getting like 53.5 gigabytes read. So just everything to auto. Also, it's worth noting this JDEC column right here is actually showing the auto XMP settings that the motherboard would run for 3000 megahertz, which is why the TRFC over there is so low, is because that's the TRFC the motherboard would be running at 3000 megahertz, because that's the TRFC of the XMP profile. Or actually, I don't think the XMP profile contains a real TRFC setting, because normally XMP profiles don't include settings like well, I've seen TFAW and TRRD on a couple memory sticks, but normally that's it. You're not going to have TRFC as part of part of your memory as part of the XMP settings. So yeah, we're just going to set everything to auto. I'm wondering what kind of a difference it'll make to the performance, but I don't have high expectations because the timings aren't like that. That's the thing with rev.E is it doesn't actually time that much better, even if you go through and set everything manually. It just doesn't make that much difference. There's not a lot of headroom in it. And the board does train for like a while, as you can kind of tell. So 32, 35, and then it'll get stuck on 40 for a bit. And there we go. And with other memory ICs, it'll actually boot up faster, but rev.E, for whatever reason, like, I just assume the BIOS isn't tuned for these sticks. So, because there should be other rev.E based memory kits that are like 4000 megahertz by spec, and I'd assume the board works with those just fine. Though I don't have any of them, so, you know, I might be completely wrong about that. And you really don't want to run anything that isn't BDI. And I can't... Where's my mouse? Oh, come on. There we go. Have mouse. So, actually, let's just check that the board retrained. Yeah, so you can see now it's all 13s, more TRFC, more everything, really. But I mostly expect this just to lower our bandwidth, and then we might have a slight hit to latency because we've gone from 1-tick command rate to 2-tick command rate. So it might, instead of being 42 nanoseconds, we might be 43, which is just like big deal, which is why I don't care about, like, you know, because I see a lot of people trying to force 1T, and it's just like, it doesn't really do that much. Oh, there we go. So 45 nanoseconds. Well, at the same time, you have to consider everything else is auto as well, so 3 nanoseconds from dialing in the timings. I put a lot of time into that, and it just doesn't go any further. So, oh, now we're getting like 43. So yeah, you can see like 2-tick command rate just doesn't bloody matter. So, because previously we were getting like, what, 41.8? And now we're hovering around the 44 range. So, yeah. Oh, I expect the bandwidth hit to be quite a bit larger. So previously we were getting like 53.5 gigabytes per second read. And now we should be getting... I actually don't know what we're going to get. Oh, we're getting about a gig less. Well, that's very, very, yeah, rev.E. Just blame the memory IC, because it just doesn't time very well. So it's like on other ICs where you have a lot of headroom over the auto timings, because auto is just like whatever the JDEC specification is. There you can actually make pretty big differences by like manually setting all of your timings. But on an IC where the like peak timings are basically the same as auto, yeah, it's like 1 or 2 gigs worth of bandwidth and like 2 nanoseconds worth of latency. It's just like, well, yay. It also, like, another thing to consider is we are on dual rank, so the actual bandwidths, like the timing hit from having loose subtimings is going to be lower because the memory controller can interleave the access between the memory sticks. So the importance of running really tight timings on like multi-rank setups is less, like it's less because the memory can access multiple like the memory controller can interleave the memory accesses. So if you're waiting on one rank to do something, well, you can do something else on the other rank, and it doesn't matter that that rank is, you know, taking forever. So yeah, I mean, I guess if you're gonna run rev.E on the master or like this kit right here, yeah, if you're gonna run these sticks right here on the master, you may as well just not bother setting any of your subtimings because it doesn't do anything. now I'm sad because I put a lot of time into that. So just kind of set your primaries and that's it. Yeah, it's also a shame the frequency doesn't really go any higher, but it's kind of that. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe. Oh, I forgot to mention, well, actually, yeah, like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly, which gives me the ability to do things like buy, you know, memory kits like this one, the one we're testing here. And then if you don't like Patreon, there's also the HOC Teespring store where you can pick up shirts, stickers, posters, that kind of thing. There's a link to that down in the description below as well. Both of those help out immensely with running the channel. Yeah, that's it there. This is rev.E overclocking on the Z390 Aorus Master. I might also take these sticks for a spin on some other boards. Honestly, like, you know, 3600 megahertz, CL15, I mean, it's not great, but considering how cheap this memory is, that's actually not that bad, right? Like, this is some of the, like, you can get these Crucial kits for, like, 70 bucks, I think, and because they're just 3000 megahertz, and you can overclock, like, so for 32 gigs only costs you like $150, and you can clock it to 3600 megahertz. Depending on how lucky you are, you might do 16, you know, you might do 16. Well, if you're lucky, you might do like 14, 18, 18 instead of what I'm running, which is 15, 19, 19. But if you're unlucky, you might also end up with like 16, 20, 20 or 16, 21, 21, right? So, yeah, anyway, that's it. Thanks for watching, and goodbye.